Okay, now we will continue to look at more engineering disciplines. In this presentation, we'll look at chemical, electrical materials, nuclear, and computer science. Chemical engineers are looking at the interaction within chemicals, basically, and applying them to manufacturing processes. For this reason, they're often called process engineers because they focus on the production of products formed through a chemical reaction. Chemical engineering often involves liquids and gases. For example, chemical engineers are studying ways to desalinate seawater. And again, they may work with other engineering disciplines to do this. So this might not just be a chemical engineering project of desalination, but it may involve mechanical engineers and environmental engineers and civil engineers. A lot of chemical engineers work with petroleum and plastics. And you see here at the bottom that it says that environmental engineering also applies to certain areas of chemical engineering. So there is some overlap there. Here are some of the industries that chemical engineers are working in. And it should come as no surprise to see petroleum and plastics listed. Pharmaceuticals is another one, and the food and beverage industries, and the environmental sciences as well. Here are just some images to also represent those industries as well. And here are some employers of chemical engineers, and some of these are local or across the country actually. And you can see again, General Mills is a food company, whereas we have some chemical companies themselves, and here we have a company involved in agriculture and producing genetically modified organisms. And also here we have pharmaceuticals. So a lot of different industries employ chemical engineers. Then we have computer and software engineering. Computer engineers deal with all aspects of computer systems, and they're really looking at the hardware side of things, whereas the software engineers are looking more at the digital side of things, and like operating systems and stuff like that. Here's a list of the kind of things that computer engineers are involved with when they are in the tech industry. And you can see it really goes from the basic elements of a computer all the way out to making sure it's ready to go before it reaches the consumer. Lots of computer engineering employers in the local area. And if you look at the bottom here, also many that are self-employed because they have a skill that they can market on their own. Here are just some products that computer and software engineers have been involved in producing over time, just to give you an idea of some of the things that they work on. And one thing to keep in mind is there's this concept of open source software, which allows individuals like you and me to create new applications and contribute to the operating systems or of some of these devices, as well as to develop new apps that we can use on our phones or computers. Electrical engineering, you can see here it employs the largest number of engineers in the U.S. It covers everything that is related to electrical devices. A lot of electrical engineers work in power plants. They work in the tech industry and many other industries as well. And actually many degrees can actually be combined with computer science and electrical engineering. So they kind of do go hand in hand if that's something that interests you in pursuing both. Here are a list of non-computer electrical engineering devices that have been created, and you can see again it runs from medical instruments to music to lighting to cell phones and power plants and energy production. And again, a few examples of things that have involved electrical engineers over time and the development of them. cell phone towers and antenna production, even, we mentioned astronautical engineers. Of course, every single shuttle going into space has electrical components, so you can expect electrical engineers would also be involved in that. And here's a power transmission line, semiconductors, you get the idea. Materials engineering is another very interesting field with a lot of new advances recently. Materials engineers, look at combining and extracting natural substances to create new materials. And often it's to meet a customer need that's been identified that could not be met with just the raw material alone. And what materials engineers are doing today is that they are combining the properties of different materials into one material so that they can enhance the strength, corrosion resistance. They can lighten the material, make it inert so it doesn't react. They can make it elastic. They can use it as insulation. They can even change the visibility properties of materials by combining the properties of two different materials. So it's a very interesting field, and I'm sure that many of you can think of a few things that have come out recently where there have been a combination of properties of different materials, like carbon graphite. If you look at sports equipment recently, a lot of it is stronger and lighter because the materials engineers have had a hand in creating these new materials that can be used in these applications. Metallurgical engineers are a type of materials engineers that work with metal only. And as an example here, they work together with materials engineers to create the stealth technology that makes a fighter plane surface nearly invisible to radar. So very cool projects there. Here are a few pictures exemplifying other projects that materials engineers have been involved in, like the development of Teflon in 1938, Pyrex in 1924, liquid crystal displays in 1968, to materials like ultrasuede and Gore-Tex and neoprene. So you get the idea. It really, again, is applicable to a variety of industries that we're familiar with. And biomimicry, which is the application of methods and systems found in nature to the study and design of engineering systems and modern technology, actually led to the invention of Velcro, where engineers and scientists learned about the sticky properties from a plant and created the same sort of adherence qualities that we use in Velcro. So very interesting work going on there. A lot of this concept of biomimicry can come from our natural systems, and one of the greatest ones is the Amazon rainforest, where we can observe nature in action and try to learn how natural processes work and find ways to apply them to our engineered systems in today's world. Nuclear engineering. Nuclear engineers design, develop, and control plants that use nuclear energy for fuel and medical purposes. They are working on nuclear-powered spacecraft to travel to Mars. A couple examples of applications of nuclear energy include food irradiation, to eliminate disease-causing bacteria like E. coli and Salmonella, and to medical and healthcare communities, the application of radioisotopes. Nuclear engineering nuclear engineers have also been instrumental in creating nuclear power plants to supplant our energy needs and avoid the use of fossil fuels. But so there's a lot of actually room for growth here as scientists are still exploring ways to harness nuclear energy for individual applications like the hydrogen-powered car. So that is a summary of all the major disciplines of engineering. So we can stop here.